1. Task Introduction. This task involves studying the basic control circuits of a 4-axis robot and the process by which a PLC controls its coordinate axis. You will gain a clear understanding of the composition of the 4-axis robot control circuit, the function of each component, the sources of control signals, and the signal content exchanged between the PLC and the servo units of the 4-axis robot. Additionally, the task covers the PLC settings, relevant parameters, and control programs required to operate the 4-axis robot. 2. Learning objectives. Knowledge objectives. Understand the basic components of the 4-axis robot control circuit. Learn the setup items and relevant parameters required for PLC control of the 4-axis robot. Understand the fundamental elements of programming required for PLC control of the 4-axis robot. Skill objectives. Accurately design and connect the 4-axis robot circuit and perform debugging. Correctly configure the parameters necessary for PLC-based servo motion control. Properly write PLC programs to achieve correct control of the 4-axis robot. Caliber objectives. Appreciate the essence of craftsmanship and strive for excellence in work. Develop a professional spirit and form a rigorous and scientific work attitude. Cultivate the habit of summarizing the training process and outcomes to gain experience for future training. 3. Guiding questions. 1. What are the 4 axes of the 4-axis robot? How are they controlled? The 4 axes of a 4-axis robot are the X, Y, Z, and A axis. They are controlled by a Siemens PLC, which outputs enable signals, command pulses, and directional pulses to the servo drive units of each axis. The servo drives then control the motors of each axis, which in turn drive the feed screws, enabling movement along each axis. 2. What is the workflow of the automated warehouse unit? The process of retrieving raw materials from the automated warehouse and placing them onto the circular assembly line. The X-axis moves to the raw material storage position. The A-axis rotates 90 degrees. The Z-axis rises to the height of the raw material storage position. The Y-axis extends to reach the pallet. The Z-axis rises an additional 40 millimeters. The Y-axis retracts to the 0 position. The A-axis rotates to a position perpendicular to the circular assembly line. The Z-axis descends to the assembly line loading height plus 40 millimeters. The X-axis moves toward the assembly line. The Y-axis extends to place the material onto the pallet on the assembly line. The Z-axis descends to the assembly line loading height. The Y-axis retracts to the 0 position. 3. How many control methods does the PLC have for the 4-axis robot? And which method is used in the training 4-axis robot? There are 3 control methods for PLC control of a 4-axis robot: pulse plus direction, dual pulse, and AB phase pulse. The training 4-axis robot uses the PTO pulse train output control method, specifically the pulse plus direction mode. 4. What is the purpose of homing the 4-axis robot? The robot's 0 point serves as the reference for all operations. Homing fulfills the following purposes. 1. Establishes the mechanical coordinate system, providing a consistent reference for axis movements. 2. Eliminates accumulated motion errors, ensuring the robot can accurately reach target positions. 3. Activates the software limit protection, which becomes effective only after homing, thus ensuring safe operation. 4. Knowledge description. 1. 4-axis robot control circuit. 1. Power circuit and control power supply. As shown in the diagram, the 4-axis robot uses Kinko servo drivers. Since the motor power is relatively low, a single-phase power supply, 220 volts, is used. The voltage passes through a power switch and circuit breaker QF0 for protection, then enters the servo driver at terminals L1 and L2. The control power supply for the Kinko drivers is also single-phase, 220 volts. which is connected to the LC1 and LC2 terminals of the drivers. 2. Feedback circuit. As shown in the diagram, feedback signals are output from the motor's encoder and sent to the servo driver's X5 port. 3. Command circuit. Servo command signals are driven by the PLC's output signals. The PLC outputs two pulse signals, one for the command pulse and the other for the direction pulse, both of which are sent to the servo drive unit. As shown in the diagram, for the X-axis servo drive, the PLC outputs signals from Y0.0 and Y0.1 to the drive units A and B pulse terminals. For the Y-axis servo drive, the signals are output from Y0.6 and Y0.7 to the A and B pulse terminals. For the Z-axis servo drive, the PLC sends signals from Y0.4 and Y0.1 to the A and B pulse terminals. For the A-axis servo drive, signals from Y0.2 and Y0.3 are sent to the A and B pulse terminals. 4. Coordinate axis homing circuit and limit circuit. The homing switches for the X, Y, Z, and A axes are proximity switches, which operate on a 24-volt power supply. The power is supplied via the switching power supply terminals L and N. The output signals from the proximity switches are sent to the PLC input terminals I0.0, I0.1, I0.2, and I0.3. The limit switch for the A-axis is also a proximity switch, and its output is connected to the PLC input terminal I0.4. 5. Emergency stop and axis alarm circuits. The emergency stop circuit of the 4-axis robot is controlled by the PLC. The emergency stop button is a normally closed switch, directly connected to the PLC input terminal I1.0. The drive alarm circuits for the X, Y, Z, and A axes use normally closed travel switches. When a moving part of the robot presses the switch opens, breaking the alarm input signals at I1.1, I1.2, I1.3, and I1.4. When these signals are interrupted, the PLC detects the disconnection and then outputs an alarm signal. 2. PLC motion control configuration for a 4-axis robot. 1. Create a control object. Click on Technology Objects, add New Object, Motion Control, Axis, and TO Positioning Axis. 2. Axis Control Parameter Settings. Select Axis, 1dB1. Then configure the following in order: Basic Parameters, Extended Parameters, Dynamics, and Homing. 1. Configure the drive. Select the pulse generator as Pulse 1. Set the signal type to PTO, Pulse A and Direction B. Set the pulse output to Q0.0 and the direction output to Q0.1. Note, for the second, third, and fourth axes, different output points must be selected for pulse and direction control to avoid signal conflicts. In the Enable and Feedback section of the drive configuration, set the Enable output signal to Q1.0 and the Ready input signal to I1.0. These act as the control signal that allows axis operation and the feedback signal indicating the drive is ready. 2. Configure the mechanics. Based on the motor model, set the number of pulses per motor revolution. Based on the lead screw pitch, set the load displacement per motor revolution. When the motor is directly connected to the lead screw, this value equals the lead screw pitch. Set the allowed rotation direction to bidirectional, allowing the motor to run in both forward and reverse directions. 3. Configure position limits. 4 axes equipped with hardware limit switches, check Enable Hardware Limit Switch. Otherwise, check Enable Software Limit Switch. The 4-axis robot uses software limit switches. Based on the travel range of each axis and the home position, configure the software limits. The software limits should be set 5 to 10 millimeters beyond the axis travel range, as shown in the diagram. 4. Configure General Dynamics. As shown in the diagram, General Dynamics settings primarily define parameters that affect the robot's motion performance, such as speed and acceleration-deceleration time constants. First, Set the unit for speed limits, typically in millimeters per second. The maximum speed is set according to the robot's maximum operating speed. The start or stop speed should be set to a relatively low value to ensure smooth motion. Acceleration and deceleration determine how quickly the robot ramps up from 0 to maximum speed, or slows down from maximum speed to a stop. To enhance the robot's motion performance, these values should be set as high as possible within safe limits. 5. Configure emergency stop dynamics. This interface is mainly used to configure the emergency deceleration of the robot's axis when slowing down from maximum speed to 0 during an emergency stop. When the emergency stop is triggered, a large deceleration value is typically set to bring the robot to a quick halt and prevent more serious issues. 6. Configure homing. Homing includes active homing and passive homing. Generally, active homing is adopted, meaning the home position is set manually rather than being determined by the robot itself. Active homing involves setting the following: the digital input address for the homing switch, the signal level of the homing switch, the homing direction, the side on which the home position is located relative to the homing switch, the approach speed and homing speed during the homing process, the home position offset, and the actual home position value. As shown in the figure, the homing switch signal is set to I1.2, active at low level. The homing direction is set to the positive direction, and the home position is located on the positive side of the homing switch. The settings are as follows: approach speed, 200 mm per second, homing speed, 40 mm per second, home position offset, 0. The home position value is defined by the variable mchome.position. Homing process analysis. During homing, the axis first accelerates in the negative direction to the approach speed of 200 mm per second. Upon detecting the lower edge of the homing switch, it begins to decelerate. Once it slows down to 0, it reverses direction and accelerates to the homing speed. It then approaches the upper edge of the homing switch at this speed. After reaching the upper edge, it decelerates to 0 again, then reverses direction once more and accelerates to the homing speed. When it encounters the upper edge of the homing switch again, it performs a series of fine deceleration and acceleration adjustments until it stabilizes precisely at the home position, i.e., on the upper edge of the deceleration switch. In this lesson, we have learned the basic components of the 4-axis robot control circuit and the parameters and settings required for PLC control of the 4-axis robot. In the next lesson, we will continue with the fundamental elements of programming required for PLC control of the 4-axis robot.